The key is value, and the value of that value key is the value. Try to keep up. Cool. Don't question me. So, now that we have our REST API endpoint set up and ready to receive JSON formatted data, if you missed that in the previous installment, have a look at us creating the web application side code first to set up that API endpoint. We were able to test that endpoint using Postman, and we added this bit of test data to the reading table as well as to the sensor table, which is now actually appearing on our web application side database. So we know that our API and web application is ready to receive actual readings from our Raspberry Pi's sensor reading application. So what we need to do now is to add the relevant code to the sensor reading application on the Pi side to be able to send that reading data across. And this is going to require us serializing our reading data before converting it into JSON format. And to help us do that, we're going to make use of Marshmallow. So Marshmallow is an object serialization library. What the serialization means is that Marshmallow is going to allow us to create schemas, which will allow us to structure our data in the correct format to be received and accepted by our API, to be added to the web application side database of our readings. So first we'll serialize our data into JSON format, and then we're going to send that data across using HTTP requests. So the Python requests library will allow us to do that. So let's jump straight into it and add some code to our sensor reading application. The first thing we'll need to do is to install those two libraries, the first one being requests, and we're also going to install Marshmallow. I'm already running my Python virtual environment, so installing into the same virtual environment that we've been working on the Pi since the start. So standard pip install for those two libraries, obviously on my side saying that it's already satisfied because I've already installed it beforehand. Great stuff. So the first thing obviously to do now is to go ahead and import. No use trying to use a library before it's actually there. Do ignore all of those little red squigglies. It's just because I'm running this on VS Code on my Windows laptop, and obviously I don't have the RPi GPIO and the Adafruit DHT libraries, for instance, installed on Windows. So my Windows VS Code doesn't know what that is, but as soon as I run the application in my virtual environment from the Pi, obviously all of that stuff is in place. So those errors are, well, not errors. Okay, so we import requests, and then from Marshmallow what we need to import is schema and fields. This is our standard sensor reading application that we've built previously the first time we started using SQL Alchemy. So if you recall, our sensor and reading classes are already there, classes that are dependent on our declarative base class of SQL Alchemy to construct our database tables and understand our data that way. But what we now need to define is two more classes which will constitute the schemas of Marshmallow. So a schema is essentially a set of instructions that are going to describe the structure of the data, essentially our data's relationship to each other and to the applications where that data is used. So Marshmallow's schema classes allows us to create data objects that conform to the structure that we define in that schema class. Now, since our API endpoint expects to receive JSON data with specific key and value pairs, such as date, the key being date and today's date being the value. DESC, description, is one of our other keys for the reading class. Description being obviously a name for our reading, so that would be temperature, humidity, soil moisture, whatever the case may be. And one of the other keys is value, and the value of that actually being your reading. The key is value, and the value of that value key is the value. Try to keep up. So now we need to create those two schema classes, which will allow us to convert our reading data into that format that the API is expecting to receive. So we pass our readings through our schema, which lets us output that data as a JSON object, which can be sent across directly by HTTP request. So it'll already be in a format that our API endpoint can understand and add to the web application side database. So the first one is, well, actually, the first one should be sensor to keep up with the order that we've been working with all along. And that will be, remember that we imported schema up here, we imported the schema class from Marshmallow, similarly to the way Flask makes use of these different classes on the web application side, and for instance SQL Alchemy makes use of these classes that we create objects of. Marshmallow works in exactly the same way. The schema class has been imported, and now we're going to create two specific classes that are classes that make use of that Marshmallow schema class to describe the kind of data that we're going to be importing. So just as with the SQL Alchemy tables up here, we essentially need to define those different column names for the data, or in this case the different keys that our data will be the values of. So our sensor schema, if you remember, our sensor table contains a date field, name field, and a pin. So again, what we call columns on the SQL Alchemy database, the Marshmallow schemas make use of what they call fields. So we've imported fields. So we use our date directly as string here. That was just an easier norm to go with right from the beginning, because we were using SQLite, which does not have a native datetime object or datetime data type. So we just define our date as a string. So each of these would be a fields dot example. So that's a string. Our name is going to be fields, also string formatted, and our pin is of course an integer. And that is now the sensor schema. So that describes the format that we expect to receive our sensor data in if it's sent across to the web application. We won't be doing that with this iteration of the program, but the idea here is that we sort of future-proof it. In case I were to add multiple Raspberry Pis to this project, for instance, each with their own bunch of sensors, every time we add a new Pi with new sensors to our project, we want those sensors to be identified in a sensor table. So we have a sensor database table to capture all of our different sensors that we have and the pins that they're connected to. So again, in this instance, this whole project, I'm only using 2 sensors. So the sensor table is really superfluous here. But if you wanted to really increase the scale of this project by adding additional sensors to your one Raspberry Pi, or by adding multiple Raspberry Pi for different fields, farmers, or different rows in your greenhouse, for instance, growing chickpeas and eggplants and so forth, then you could do that. Okay, don't question me. So, and then the next schema is reading schema, which is the one that we're going to be making use of a lot more in this iteration of the program. And again, if we remember, our reading class has these 3 different columns. We're not going to identify an ID, because on the web application side, the database auto increments that ID. So it defines the ID for each new reading by itself, because that's a primary key value that increments on the database side. So we don't have to specify an ID. That's created automatically, because that's a primary key field. So the same way as the local database here on the Raspberry Pi has ID as a primary key, a column which is a primary key, we'll have the same thing on the web application side's database. So we don't have to specify that, but we do have to specify the other fields, which is again date, a string field, got description, which is also a string field, and we have the all-important reading value, a float field. Now, every time that we want to send data across in an HTTP request, every time we want to add a reading to the web application's database, we now have the schema that we can pass that raw reading data through first, and it'll spit out some JSON data for us to send across in the request. So if we scroll down to the area where we're actually collecting our readings, we now want to serialize each one of these readings by creating an object from our reading schema before we can send it across in that request. Okay, so for each one of our readings, we want to convert each individual reading into a JSON formatted bit of data. I shouldn't say bit, I should say chunk, piece of data, section of data. You know what I mean. We're now creating an object using our reading schema, and the Marshmallow schemas has a method which is called dumps, which turns whatever is passed through that .dumps is essentially turned into JSON data. So if we look at temp reading being an object, being a reading object that already has a data, description, and value field, we now take that same temp reading and we dump it as JSON data. So we pass it through to be JSON data. So that is temp reading. So now we have a JSON object of our temperature reading. We're going to do the same for the others. Humidity being one of our humidity reading. Moisture. I type out moisture because I know our sensitive viewership has such an aversion to the word moist. 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 So we've got JSON temp, which is JSON dump of our temperature reading, JSON hum, which is a JSON dump of our humidity reading, and JSON moisture, which is a JSON dump of our moisture reading. And now that we have those three converted, we now have the three pieces of data that we can send across in our HTTP request. So now we're going to make use of our requests library that we've imported here, and we're going to call the requests.post method to actually go ahead and add those readings to a call. The way we're going to do that, if you have a look at the requests doc, what you need to tell it in the event of a post is which URL you're posting to, the data that you're actually posting, being key value pairs, that is already JSON data, but we have more than one key and value pair here. Each reading consists of 3 key value pairs. Another useful thing, I'm not seeing where it is in the docs here, but if you scroll through it, you should be able to find it. There we go, headers. So another good idea is to send a header across. Because our API endpoint is expecting specifically the JSON data type, useful to make use of a header which is sent across with our request, and that header telling our API endpoint beforehand that we are using JSON, that we're sending it JSON data. So I'm going to declare a few variables here. First, I'm going to declare the URL that we're sending the HTTP request to. That in this case will be the IP address of the web application server, which is my laptop. But if you had an actual website, for instance, you would post the full URL. Now, if we recall, the Flask-Restless API endpoint that we created is created under the subdirectory /API/ whatever that model name is. So we have 2 API endpoints, one being /API/sensor, and the other one is /API/reading. Just for a placeholder, I'm going to put the localhost IP address there just so that you can have a look at what that would look like. Oh, no, that was a mistake. API reading. Again, in the actual iteration, I'm going to be changing that to my real public IP address. In your case, you change it to the public IP address of whichever device you're running your web application from. The default for Flask applications is port 5000, and our API manager has created our API endpoint right there at /API/reading, and the other one at /sensor. The header, again, we're going to tell our API endpoint that we're giving it JSON data. So you give it a content-type header, and the content type in REST API language is application/JSON. I don't think that it's necessarily a requirement to add that header in, but it is good practice. There's many different types of headers that you could add in. If you were adding, for instance, security measures to your API, and your client or your user that was doing API posts or HTTP posts was required to authenticate themselves, you could have something like an API key included as a header in your request. So a lot of public sort of API services that you will interact with in a commercial context would have things like API keys or client authentication certificate files and those sorts of things to authenticate users, so that not just anybody can be adding data, posting data to an API. But again, in our case, this is just a small application. All I have is 2 endpoints, and it's still very simple. But all of that sort of authentication can be added if you were feeling adventurous, or if you were preparing this to actually be a public service, a public API. So again, calling our requests library, you do a post by doing requests.post, and the 3 arguments you pass in is the URL to be used, which is our URL variable up there. You tell it what the headers are, the header just being that one header, and you tell it what data. So we have 3 pieces of data. We're going to do 3 separate post requests. The first one being JSON temp, and we're doing 3 of them. Boom, boom. Not with a double S header, not header S, it's just header. Headers with one sh. Okay, JSON temp, JSON hum, and JSON moisture. Righto. Might be a good idea just to introduce a small pause here. Do a time.sleep 3 or 5 seconds in between each, just in case there's some kind of exception raised from each one. Be a good idea just to put that buffer in between them. I've already increased our time.sleep here to 60 seconds while we still have this session that we've opened up here. Because there is an open session, we're gathering our readings, we're converting it into JSON, and then we're posting each one of those readings JSON data across to our API endpoint. Isn't that something? That should actually be it. Yep, that's all we need. Let's go ahead and test. I'm just going to add in my actual IP address off screen. In the meantime, this is still running. So our web application is already running and our API endpoint is ready. Let's go ahead and do this. Let's test REST post. Say that 5 times fast. So we're going to run, and in the order that things happen is we can see it's first created our database. Oh, it's created a database anew because it's a new file that I've created. And there we go. It's already gone to the point where it's successfully inserted into our local Pi database, and it's printing on our terminal. So we should already see 3 new readings having been added. If we look at our values here, this is our posts, requests, and our adding to the database happen before printing to the terminal. So the fact that we see it printing to terminal here means that it's already completed everything else without exception. So if we refresh on our reading page, if we refresh 3 fresh readings on our reading table, and would you look at that, there they are. Again, relative humidity is completely off the charts due to that stuffed sensor of mine, which I've not had a chance to replace yet. We're all still on lockdown, as you know. But there we go. There's our 3 new readings having been added to our reading table successfully. Those are 3 readings that came from the Raspberry Pi. And if we look at web application running in this PowerShell window here, there you see those posts coming across from the Raspberry Pi's IP address, and our API giving a 201 response, 201 meaning OK and content created. So if we refresh again, so there's another set of readings having come through there, and it'll continue to do so every 60 seconds. So there you have it. Isn't that something? We've now created a web application that's hosting a REST API endpoint that's ready to receive all of these sensor readings and different JSON data from each one of our Raspberry Pis out in the field with their sensors collecting environmental data. That really brings us to the end as far as the functionality of this PyPlant Monitor project goes. This is all of the functionality that we need to run a basic residential project where you're hosting your own little web application on a laptop and you've got your Raspberry Pis adding reading data to it. You know, obviously depending on the time.sleep value you select in your sensor reading application, you can cause it to do that once or twice a day. What you could also do is to use the PyJuice, and you can configure that PyJuice to automatically power up your Raspberry Pi and have that Python script of your sensor reading application run automatically whenever the Raspberry Pi powers up. Take a reading, post that reading across to the web application that's running at all times, and then power back down. So you can have that sort of functionality added whereby it's working only once a day. And if you do let the Raspberry Pi only power up, say for 5 minutes at a time, you could very comfortably run the Raspberry Pi and PyJuice off of a solar panel and not have it connected to power at all times. So the PyJuice is something that's really useful to add mobility. It's almost like a UPS, an uninterrupted power supply for the Raspberry Pi that can be programmed to, as a smart power manager really, it can be programmed to power up and power down the Raspberry Pi when you need it to. Have it automate that sort of functionality. You don't have to power up the Raspberry Pi yourself or keep the Raspberry Pi running for 24 hours a day. But that's really it for now. I might decide to add some more information to the PyPlant Monitor. It's also possible to host this Flask web application across something like Python Anywhere or any other kind of hosting facility. Then you have a public website that you can add SSL certificates too, so you can have the whole thing secured with HTTPS. And then you really have something that's a lot more robust and that can be run over the long term. If you have been following along with this whole series, I really appreciate it, and I hope that you found it useful and that you've learned a bit of Python, you've learned a bit of Raspberry Pi, and that more importantly, that the ideas have started churning in terms of what else you can do with these kinds of functionalities. There's really no end to the kind of projects you can get at if you are creative. Leave us some comments and let us know how the project worked out for you. What are the difficulties you've run into? What are the successes and the triumphs? What has made you scream and cry yourself to sleep for weeks on end while trying to do this project? For me, there's been plenty. Trying to get your virtual environment activated on Windows, that was quite a thing. Trying to get VS Code and the Raspberry Pi to talk to each other, that took a moment. And getting my data successfully serialized the first time I did this last year, which was also using Marshmallow, but I had no idea what schema and class meant, so I was just kind of following along like a parrot with somebody else's instruction, and it really hurt me in the long run because I could have known how all of this stuff worked properly already a year ago. So just spending the time to sort of figure it out for myself was really useful. So I'd really recommend, as much as I'm sure following along with the series is useful, and I will make all of the coding for the series available on GitHub, I really recommend having a look at the actual documentation of each library that you make use of for these kinds of projects, and try to recreate and understand what each line of code actually does, because that does so much more for you in terms of learning in the long run, but it also does a lot more for you in terms of understanding what these applications do bit by bit. So it gives you a granular understanding, and it starts to get the wheels turning, or the cogs churning, in terms of other places that these bits of code can be used for other kinds of applications. Whoever has been following along, thank you for following along with us so far. I hope that you found the series valuable, and there will be more projects coming up soon, but until then, do keep learning things the hard way.